My primary goal is to make a hash map, but for that I need to be able to compare objects and hash them. Right now I want to start building the equality function, and I want a generic equality function that also works on deep objects. If we compare any two objects in JavaScript, we'll compare by object ID. So even though the shape of the object's the same, if we compare those two, we can see that the result is a false. But if we tried A equals A, it would work. Here. Now, this does not apply to native values. That means if we compare strings, for example, this will evaluate to true, even though there are two different string literals. This just happens to be the way it is. And the types this count is true for are quite a few, but it counts for null, it counts for string, number, big int, I believe, undefined, string, number, big int, undefined, null. Did I forget any? Boolean, I forgot the Boolean word. Value. Sorry, mixed my German in. For every other type, the equality symbol does not work in TypeScript and JavaScript. So my goal is to write an equals that will work on any shape of object with some restrictions. So the shape of a function I want is just an equals function that takes two arguments and returns a Boolean value if they're equal. Now we could try, let's try simple, let's just compare two strings in the beginning. And then we can return simply self equals the other. And I'm going to build this iteratively, and I've set up a test case since I'm running just inside Node to run the code. That is not the best way to do this, but it's the way I'm gonna do it. So if we run this with two times the same string and once with different strings, we'd expect to see once a true and once a false in the log. True, false. Now, just comparing strings isn't that interesting, so let's also add numbers. So we added numbers, and we could now also compare to a number, for example. And this will have the same output, true and false. We're not doing anything special yet, true, false. But the more we add here, the more annoying it's going to be. So let's extract this as a type. Let's call these native equality, or has native equality. And we can say it's string, number, and instead write has native equality here. Ignore the hash function. Come on. Has native equality. This does not change anything because all we did is move this up here. But we could now just define it over all of them. This will still work because we just established these are the native equality ones. At this point we have one equals function that functions over all native types. It's not that useful, but just to convince ourselves this actually works. For example, if you write in here true and false, this will evaluate to false. And on the other hand, if we write undefined and undefined in here, this will evaluate to true. I did not want to run it in debug mode. Right, so true does not equal to false, that's correct, and true undefined equals to undefined. Now, we could consider if we want to deal with undefined in a special way, that undefined is always false, but I leave it as true. Now, let me format this slightly easier that this fits on the screen. We want to support more complex objects. For example, if I write here a object into here, we'll get lint complaining and TypeScript if we try to compile it that the argument is not of type has native equality, which is true. An object does not have a native equality. So let's make a new type and let's call it equalable, maybe. And it is of a shape either native values or the empty object, for example. So we can define a object, the equalable object, using the square bracket, the curly brackets. And if we can then define a pattern for the keys, for example. So let me type it out. The way this type can be read is that it is an object whose keys are of type number and whose values are all of type string. Let's restrict ourselves to string keys first. And let's say it can contain any native values. This is a shallow object for now, but this makes our life easier in the first place. Now, types can be circular. That does not count for records. That's a special utility type called record that doesn't like circular references. I'm not sure why they decided to do that, since a record is literally just this. But okay. So, and instead of using the native equality here, we want to use the union type of those two. And we can see our error here in the test disappeared. This is now true. Now, our test here will not work anymore for this shape. And this is what we're interested in establishing now, is how do we compare two objects with each other. Like, if I just run this, this will be a false. But we'd like it to be a true. Well, one way we could do is check if the object itself is of type if self is type of object. Type of gives us some of these values, not all. Null, for example, type of null is object, which is kind of annoying. But if the type of object of self is not the same type as the other, if the types are not the same, we know it's false. We don't care at that point. Like, a string will never be equal to an object. I mentioned just now that if one of them is null, it'll actually cause a problem. So let's escape the nulls quickly. And I'll demonstrate this in a second. So if one of them is null, we just compare them. That means if both of them are null, it's true, and null equals some other thing is always false. So this will give us the comparison. Let's demonstrate why we need to do this. So if we do a type of null here and block that out, we'll see that the type of null is actually object. And if we try to iterate through the properties of null, we'll get an exception. I'm again not entirely certain why this is the way it is in TypeScript, but it is just a fact of life we have to deal with. That is why we bail if the object, if it is a null actually. We want nothing to do with null. Next thing is we could check if it's any of the native types that are left that is not null. To know whether we are actually we can just check if we're an object now. So if type of self equals object, now we can do something else. I just say return false by default for now to just get rid of the errors. So what happens here is if the type of a left and right argument are not the same, we already say no. So we know that if self is an object, that other is also an object. And what we can do now is extract the entries from self. And from other. And object.entries gives us the list of properties with the keys in the object itself. Now it only gets us strings keys, so if you have different key types, we're gonna have issues, which is why I'll be restricting this to just strings. And the .entries, .values, and .keys functions on objects have issues. They're just bad type-wise. So if I copy here the type hint, this is the that actually worked this time. Sorry, it would not work in later examples, and I'm sure we're gonna run into that issue. But usually it doesn't know what the second argument is. So entries extracted into pairs of the key and the value. Others has an issue here because we only checked here for self. We know that their type has to be the same, but TypeScript sadly does not. So we can just assert that it is indeed a equalable object. And then that'll also leave us alone at this point. And we now need to somehow compare these two arrays. Well, first step would be to step through them at the same time in parallel. Sadly, TypeScript does not have a zip function, and I'm not going to write a zip function now. I'm going to do it manually. Maybe we'll visit how to write a zip function. But for that, we also want to step it in a ordered way. So we want to sort our objects first. So let's do that. Let's sort this, and we want to sort it by key. So let's take the first of the, actually let's use pattern matching here. There, destructuring, not pattern matching. And then we can compare the left to the right key and sort it this way. We can do the same thing for the other values. And now we know our list of keys has the same order if I have the same values, and a key has to be unique, so we know there's not going to be the same key in there twice. Now we can do a quick sanity check. If self values length is not the same as the other value length, we know that they can't be the same because they have different numbers of keys. It's just not possible at that point. Now that we know that they're in the same order and have the same number of elements, we can step through them in parallel. And we know that every value is also comparable or equalable. So we can now just check for each pair if they are the same. So if, let's extract them as values here. This is the self. Let's call it left and right. This is of the self values, the ith value, and this is of other values, the ith. Now I have here a check that if I'm using an index on an array, it could be undefined. In this case, I know it's not undefined because I have the bound check here. But TypeScript's warning me here, that's why I need to do the exclamation point, that it could be undefined and you can't destructure a undefined value. So we're just asserting that this is indeed not undefined. Now we can check if the left and right value equal each other. And if they don't equal each other, we return false. And we can rewrite this in a reduce just right now. In the other case, so if we encountered a pair that was not equal, then we return false. If we ran through it and we didn't encounter such a pair, that means all of them were equal and we know that this is correct at this point. Now let's rewrite this as a reduce. Can we rewrite this as a reduce? Not without a zip. So let's not rewrite this as a reduce, but once we have a zip, we could rewrite this as a reduce. This should work. We can convince ourselves that this works if we run the test here with no objects in it, with just the empty objects. This should be evaluated to true. It does. And let's also put in some value. And this should also evaluate to true. On the other hand, if their values don't match, it should evaluate to false. The first one is true, the second one's false. That's nice. Now, another thing we want to check is arrays. Like, we also would want to be able to input arrays here, like such, and know if they're equal. The problem is we can't currently do this because our type here does not allow for arrays. We can extend this simply by saying an equalable is also allowed to be an array of itself. And I used the wrong type here, sorry. This should be this type. That's a type from a different function I'm writing that I'm importing by accident. But it actually doesn't change anything for us. Now the exception here went away because we're accepting arrays. But we're going to have an issue here. There is no way of checking for an array directly by type of. Arrays are also just objects. But there is a helper function in the array class, or namespace, with isArray. So we can check if self isArray, and let's add another guard, and if the other one is also not array, is array other. No, we can't do this with a nested if, I guess. And if the other one is array, let's add in here a guard and say if the other one is not an array, then return false. An array and a not array is not equal, so that's fine. Now, in the case where both arrays, we can do the same thing that we did down here, but we don't need to go through the keys anymore. We can just iterate through them. So we add the same check on the length, and at this point TypeScript knows their arrays. And then we can just abuse the same loop. We iterate through the self values. We grab the, we don't need to destructure anymore. We check if they're equal. Return true if all of them are fine. And we can test this on the right side, if this works for us. It returns true for the shape 1, 2, 3, 1, 2, 3. If we return 1, it should now return false. I don't want a breakpoint. And it returned false. One more thing. What would be a lot more pleasant is if we could also nest them, if we could put in an arbitrary shape. Currently we can't do that because our object here is hard-coded to only include native types. We can simply replace this with the equalable, and this will already just work for us because we're using the function recursively here. So we'll be then doing our type checks up here again, and that is everything we need to do for this. If we run this, this should equal to true. The second one, because the first one is this one. We see this is true, this is satisfactory. Let's add another test. And make it a bit deeper nested, just to convince ourselves. And let's also nest an array. Like so, for example. Let's remove this log. And ordinarily, I'd be actually writing these as tests and leaving them in. But I don't want to clutter this with just test writing, right? And we got a true. So if I change the most inner one, we should now still detect the change. It's a false now. And that is it. That is how we can write a deep equal in TypeScript. That is type safe. Let me just get rid of some of the exceptions here. We already know, like I said, that this is safe. We could also consider refactoring something here, because the shape of the object is near identical to the shape of the array. For example, if we also just, after the sort, added a map and just extracted this, then this would be the same code. I'm going to leave it as is for now. One thing to note is we're not supporting function equality. and class equalities. That is because there's no trivial way of actually comparing them. Comparing a function, we could use the function identity, but we can't compare the content of the function. And with classes, there's the same issue. We can't really compare their prototypes. When is a class really another class? So we can compare the prototypes, but it's a lot more complex to compare to classes. We could extend this at some point of time to also support class types that implement a specific interface that offers the classes to have an equals function, and then we could call that equals function instead. Let's also quickly export that type here. Not that type. Let's also still export this type so that it is usable for functions that accept equalable. One restriction of our hash maps will be that they'll be only working on equalable, because hash maps need to call equality. Hash maps need to do equality checks. If you've got any questions or want to ask me something, leave a comment. Feel free to join my Discord, it's in the description, and I'll see you around.